We're sitting here with another team at the AICC Challenge, which is the AI Cybersecurity Challenge. They were supposed to make an autonomous team to both find bugs and automatic patch them. There's whole content around what it is. We want to sit down with you guys talking about your approach, what you did, how is your approach different than other teams, how it works, some of the challenges. So let's start off here. When you guys first heard of this challenge, why did you decide to join the AICC?
Maybe I can start. So I heard this challenge in Black Hat 2023, if I remember it correctly, because my student and I are presenting our works at the Black Hat. And when Perry Adams announced that the DARPA is going to have this competition, it's going to explore whether AI techniques can be used to solve some security issues, especially to find bugs and patch bugs. And I think it's quite exciting, and it's a very interesting topic. And also, as someone from academia, we also always wants to explore something that nobody else has already explored, right? So that's. And then I quickly shared this information with some of my other friends, including my previous advisors in academia, and asked if they are interested and if we can team up or something like that. Right. So that's basically how the story begins. It's like, okay, interesting thing, we should do interesting things. That's it.
So you formed a team, you started it. Was there a baseline of like, here is how I think we're going to do it? Because you were allowed to use commercial tools if you wanted to. You could use an off-the-shelf orchestration system. You could kind of decide how much of large language models what you wanted to do. What was like your initial approach of how you thought you were going to build it, and then how did you end up building it?
Oh yeah, so that's a great question, because like the techniques to find bugs and patch bugs have already been developed for decades. There are lots of mature tools like fuzzing tools, static analysis tools, and of course at the very beginning we always want to explore whether these tools can work or not. Right. So at the very beginning, I remember it's like about 3 months. We have lots of debation, lots of discussion, and lots of like evaluation of the existing tools. And we're trying to figure out, okay, whether this tool works, whether that tool works, and how can we introduce machine learning techniques to kind of like orchestrate these tools. So have lots of testing, lots of evaluation, and we come up with a very initial design, which is, at the very beginning, we propose a solution is like we are going to be build lots of agents in the system, using these agents to, for example, call this tool to get some results, and using the agency is based on large language model, right? So, and the agency is going to use the reasoning capability provided by the model to orchestrate the traditional tools to get results that we want, and how to put the output of this tool to the as input to another tool or something like that. So that's our initial solution. And during the competition, we gradually find some limitations of existing traditional tools and also limitations of the foundation model. So we modified our design a little bit, and we're trying to figure out, especially trying to figure out how to deal with hallucination of the foundation model. And finally, we make our final approach is like we still have lots of classical tools in our system, but still we are using foundation model to kind of like, for example, use it to develop patches, and we also use foundation, use some like, maybe we can call them classical AI techniques, not like large language model, something like the neural network or something like even like decision tree in our system, and trying to do some small tasks, and then we're going to use a system that are going to orchestrate all these classical tools and also AI tools.
So just a little bit of background on your team. Have you guys competed in traditional DEF CON CTF before? Are you a relatively new team? Have you all attended DEF CON previously?
Yeah.
Okay.
So this guy is from the
yeah.
Maybe
yeah. So I was previously played DEF CON for the Cat Zipin. Yeah, its previous name is AOE. Yeah.
Okay.
Yeah, and I was previously affiliated with another team called the Down Team.
So in your solution for the Cyber Challenge, did you use any existing frameworks from your prior interactions with either DEF CON CTF or prior? I know there was a previous competition, the Grand Challenge. Did you use any existing frameworks that you were already using, or did you spin up everything new for this challenge?
We're not starting from scratch.
Okay.
And unfortunately, I didn't have the chance to participate in the grand challenge because at that time I'm still, I'm still doing my undergraduates. So we use lots of existing tools like the AFL and also other tools. But I think because I mean it's a challenge, right? So challenge means that you cannot just build a system using the off-the-shelf tools. You must have some innovations in it. Right, so we use some existing techniques, but we also introduce lots of like emergent techniques, lots of new stuffs into the system. Yeah.
So you say emerging techniques. What, can you explain what one of the emerging techniques would have been?
Oh, yeah. So yeah, emergent techniques. I mean, in this context, is of course the machine learning techniques, right? So lots of different machine learning models, not only large language models, but also other techniques that we can leverage to make the system more automated and make the system to be less Oracle guided.
Well, be more specific. Like, what technically were you adding on that was something new, novel? Which you said it's an emerging technique. What specifically?
Oh yeah. So because this system is trying to find bugs and patch bugs, right? So we have different components, or we call them subsystems in the tool, and we have components for the for finding bugs, component for patching bugs. So for patching bugs, we are mainly relying on the foundation models, large language models, and we also use some tools to verify that the patch generated by the model is correct and does remediate the bugs. So that's for the patching components. And for the components that's trying to find bugs, because in the finder we have a new model which is called delta model, which basically is like we have some code change, some code diff, and trying to figure out whether this code diff will introduce new bugs or not. Right. So we use an existing technique which is called direct fuzzing to find bugs in the code diff. But the direct fuzzing basically means that you must have some guidance about where the fuzzing should go. Right. So we must give some feedback to direct fuzzing, and we introduce some machine techniques trying to prove the call graphs generated by classical tools. For example, the classical tools can always generate some false positives, which will make the efforts diluted. But the machine learning techniques is able to prune some core edges in the call graph, and then we can be more focused on the target. Some examples. Yeah.
So this competition went over the course of 2 years, and we all kind of know that the large language models have gotten a lot better in the past 2 years, and some of them have gotten worse. But did you find anything surprising as time went on about how your techniques started using the large language models versus how they were, we'll say, in the second year? Like, how did your approach change over the first year to the second year, maybe with the patching mechanisms or the guided fuzzing mechanisms? Did anything surprise you?
Yeah, of course. So personally, I think I kind of underestimate the large language model at the very beginning. So it's almost 2 years ago. At that time, we only have models which like GPT-4 and the Cloud 4 wasn't there, right? And GPT-5, yeah, of course, wasn't there. So I kind of like underestimate the capability of the large language model. So at the very beginning, we have lots of doubts about them. So that's just why we choose to use, for example, lots of classical techniques in our system. But the development of large language model is, very surprising. And nowadays, people are talking about like agents, and agents wasn't there about 2 years ago. So yeah, I have to admit that we kind of like underestimate the development of large language models. So actually, that I don't think we fully leverage the capability of large language model, which is actually our future direction. Is like we want to introduce more techniques from the large language model to trying to make our system better and to be more general across different software.
Yeah, it's interesting to me when we talk to the other teams is it seemed that the teams that did better in the contest relied a lot more on the large language models than others, where they didn't just use the classical tools, and the ones that really embraced it and pushed forward. Did you notice that as well? You guys, do you think one of the things that made you do better in the contest was that you relied on large language models more, or that you relied on more of the classical attacks more?
So maybe.
Yeah. I think there are different stages. I mean, at the very first beginning, we'll like try to find bugs, and the next one we will try to fix bugs. And for the portion of the large language models, I think most of the credit or large language models are used to generating patches. And for the very first stage, I developed a system that for generating POC or initial seed for fuzzing. This is a combination of like a traditional way and AI way to find a kind of a effective path to a potential vulnerability sync point. And for the finals, they introduce another mode, like a serif mode, which is like they broadcast a static analysis result in like kind of JSON format, and they just want us to verify this is true positive or false positive. We use pure large language model, the AI way, to verify the results, and thanks to the MCP, because MCP, the model context protocol, is very new in this year, and it's very popular. So thanks to MCP, we can integrate very fast with large language model. Yeah, and this part is pure AI, I think. Yeah.
So I know that the teams obviously have been working in relative secrecy, across from each other, but the contest was structured such that everyone needs to open source their solution at the end. Have two questions. Have you gotten any time? I know everything just got released and you're talking about it. Have you gotten any time to look at what the other teams did for the competition? And are you planning to go back and continue working on your current solution to evolve it further?
I think kind of improvement. I think for the AI portions is I had to admit that we underestimated the power of the large language models portion. So I think for the most significant part should be we can use everything. We can use AI to everything, every part of our component, and it will. I think from the results, yesterday I saw every team use large language models in every part of their component. I think it will be significant.
Yeah. So after the announcement, we actually have lots of discussions with other teams and trying to explore like what other teams are doing with the agent and the large language model, so that's why I'm thinking because kind of underestimate the capability of large language models at the very beginning. But I think it's the end of a competition, but it's not the end of the game of exploring large language model for vulnerability finding and vulnerability patching. That's just a start, right?
Yeah, it's been fun asking the teams, like, in hindsight, what if you had perfect vision of the past, what advice would you give to your past self? And a lot of teams are saying that we wish we would have relied on them more, we underestimated them. Is there something specific where if you could give yourself one piece of advice before the contest started, what would that advice be?
So for me, actually, our team, the system that developed by our teams are very excellent at finding bugs. So actually, we are the second in finding bugs, and we are the first reporting the serif reports. But we are not doing very well at patching bugs. So actually, it's not because we are not using large language model a lot. It's because some small bugs, some small but critical bugs in our integration, right? So if I'm going to give some advice to myself, like 2 years ago, I would say we should put more efforts in integration, put more efforts into the engineering things. But more importantly so I'm thinking maybe we can, instead of using the oracles or heuristics to integrate the system, I would say, okay, could you explore more potential of using large language model to integrate the system? Because large language model is likely to be more general and more flexible than the traditional approaches.
What about you guys?
Yeah, for me, it's do not change the code at the deadline. Yeah, we did pretty well, like the vulnerabilities. Yeah, we won the second place. Yeah, find bugs and submit them. But yeah, as you know, the scoreboard, we didn't patch so much. Yeah,
Yeah, that's why we introduced a small box at the deadline before the submitting the code to the DARPA. Yeah, and that the small mistake provide us submit 80% of our patches to the final. Yeah, so if I said to the previous myself, I would say just keep the code, do not change at the very end. Yeah.
Yeah, it's actually very interesting. Is like actually we found these small but critical bugs after we submit all the codes to DARPA. So actually we already know that our system is likely that because of bug, our system is not fully behaving itself. Yeah.
Well, hey, thank you so much. Again, your team was 42 beyond bugs.
Mhm.
Hey, thank you so much for sharing. I cannot wait to dive into your system when you release it. Thank you for sharing with us. Thank you for watching, and hack on.